Number 22. In triangle ABC, angle B is a right angle. So I immediately want to draw this. Okay, so I have angle B is a right angle, and this is A, weird A, ABC. The length of side AB is 10 times the square root of 37. Okay, so 10 square root of 37. And the length of side BC is 24 square root of 37. What is the length of side AC? Okay, so immediately when we have a right triangle and we have lengths of sides and we're asked to be able to find the length of a missing side, we immediately want to be thinking of the Pythagorean theorem, which is that a squared plus b squared equals c squared, where a and b are the legs or the shorter sides of a right triangle, the ones that are forming that right angle, and that our c is the hypotenuse, the longest side, the one that is opposite the right angle. Right, so that's what we want to be thinking. But there's one other little consideration on this, is look over here at our answers. All of these answers are being given in the form of a square root. 14 square root of 37, 26 square root of 37, etc. So there might be a little shortcut. Woo, went in instead of out. There might be a little shortcut to be had here in a minute. We'll see. Let's see. Okay, so I'm going to do it sort of the regular way, as it were, and then I'm going to show you a little shortcut that applies in this particular case. I'm doing it the regular way first because that will apply for any problem that is like this. So if I have my two sides that I am given, my two legs, and I'm asked to find the hypotenuse, the c of the a squared plus b squared equals c squared, I'm going to take those two sides and I'm going to square them. So my one side, my a is 10 square root of 37 squared. My b is 24 times, I wrote parentheses in the wrong spot there. Come on, undo. There you go. You can do it, whiteboard. 24 square root of 37 squared is equal to c squared. So when I square 10 times the square root of 37 first, since that is 10 times the square root of 37 times itself, 10 times the square root of 37, since these are both times, I can reorder things. That's called the commutative property of multiplication. Ooh, big fancy word. So when we reorder them, we would get 10 times 10, I'm putting those two together, times square root of 37 times square root of 37. So 10 times 10 is 100, and square root of 37 times square root of 37 is just 37. So all together, all of that means that 10 square root of 37 squared is 37 times 100, or 3700. Okay, on to our next one. We have 24 square root of 37 squared. Same exact thing applies. It is 24 times the square root of 37, and when we square it, we multiply it by itself. So times 24 times square root of 37. And then we can reorder those. I'm going to just swap these two locations. So 24 times 24 times square root of 37 times square root of 37. So 24 times 24 is 576. I'm actually going to replace that there. 576. And then 37, square root of 37 times square root of 37 is just 37. And then 576 times 37 is, get rid of all of that, 21,312. And so if I add 3,700 to that, I get 25,012 is equal to c squared. So I want to solve for c. So to undo c being squared, I need to take the square root of it, and I need to do that to both sides. So now c is going to be equal to the square root of 25,012. Now, that can be a little bit challenging to find all the factors of 25,012, but we have a big clue, because up here in our answers, we go back up here, all of these involve, in some form, the square root of 37. So I know 37 is going to be left behind, and either, so 37 is going to be in there, I should say, and either it will be left behind and I'll have a square of 14, square of 26, square of 34 under the radical that I can then pull out, or I'm going to have, it's going to be 34 times 37, either way. So I'm going to divide 25,012 by 37. So 25,012 divided by 37, just to see what would happen when I do that. And I get 676. All right, so I'm not getting 34 times 37, so that one's out. So 676 must be the perfect square of either 14, 26, or 34. So I can take the square root of 676, boop, and I get 26. And so what I'm actually doing when I'm saying all this, just I'm going to write it out to be clear. I've discovered that the square root of 25,012 is equal to 676 times 37. And when we have square roots like this, we have like the two numbers being multiplied together under the square root, we can split them up. So you can say it's equal to the square root of 676 times the square root of 37. And we've just learned here the 676, its square root is 26. So 26 times the square root of 37, and you don't really have to have that little dot. You can just say 26 square root of 37, which is B. I mentioned a kind of shortcut that is true in this one. And this is just going to be bonus information. The way that I just showed you, a squared plus b squared is c squared. You do the things, you take the square root, and then you see which one of these it is. That is going to work on every single one of these types of problems where you're given two legs or a leg and hypotenuse, etc., of a triangle. You plug the two in, you solve for the third. That will always work. Okay, this is a little side note, kind of a little bonus way of looking at this that applies in this particular case and is just kind of showing you some interesting things, I hope, as far as how you can do this particular problem a little differently. Okay, you go back to this point where it's a squared plus b squared equals c squared. And you can look at this as you are pulling greatest common factors out. So this first one right here, 10 times square root of 37 squared, is, as we stated before, 10 times 10 times square root of 37 times square root of 37. And then we have 24 times 24 times square root of 37 times square root of 37. And just like if I had like 2x plus 2b, I could say, oh, 2 goes into both of those. I can pull it out. 2 times x plus b. I've pulled out a factor of both of those. I can do the same thing here. So here I have these two things being added together. I can say, oh, they both have square root of 37 times square root of 37 in them, which we mentioned before. Square root of 37 times square root of 37 is 37. So they both have 37 in them. So I can pull that out and say 37 times 10 times 10 plus 24 times 24 equals c squared. And move that up. Okay, 10 times 10 is 100, and 24 times 24 is 576. So 100 plus 576 is 676. So it's 37 times 676 equals c squared. And you go, okay, I'm going to take the square root of both sides. You go, square root of this equals square root of that. I can split those up to be square root of 37 times square root of 676 equals c. And we're back to where we were before, where square root of 676 is 26. So 26 square root of 37. That's just a little quirk of a way you can do it for this problem. I think it's a little quicker. But honestly, I don't want you staring at a problem trying to see if there's something like this going on in it when there is a relatively straightforward and doesn't take that awful long, normal, we'll say, quote unquote, way to do it. this way, something like this will work. This is the kind of thing where if you do enough math problems and you do a lot of practice for the SAT, you might start seeing these little loopholes or alternative ways to do things. And, it can save you time if you see them. But again, if you don't see them, it's no big deal. It's just another way to do it. The traditional way will serve you just fine. Hey guys, head over to my new site, mathwithalyssa.com, to get your free 10-video course of SAT tips and tricks. It covers things like how to make a study plan that's perfect for you, how to pace yourself during the test to get maximum points, and so much more. I'm super excited to get this out to you guys, and a lot more SAT prep help is coming for you in the weeks ahead. Again, that is mathwithalyssa.com. And if you liked the video you just watched, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.